One example here is when you are having this kind of a two-port network where this is port 1 and let's say this is my port 2. How would you go about finding the Z matrix? So your Z11 is V1 over I11, I2 equal to 0. Why is that so? Because when you expand the matrix, V1 is Z11 I1 plus Z12 I2. So Z11, this term is V1 over I1 when I2 is 0. When I2 is 0, right? So when I2 is 0 means that means there's no current here. That means this has to be an open circuit. When this is an open circuit, you realize that this circuit becomes simply like this. There is an I1 that is going in and there is a V1 here. Because there is no current flowing here. This when I2 equal to 0, there is no current flowing here. This reduces to this. Whatever current comes here is flowing through here. Nothing goes through here. Imagine it that way. So all of it is going here. That means it's what? ZB plus ZC. These two are connected in series. And the whole thing is connected in parallel to ZA. So Z1, Z2 over Z1 plus Z2. Z1, Z2 over Z1 plus Z2. Huh? When two impedances are connected in parallel. So when you go ahead and do that, this is my Z1, this is my Z2. When you do that, it's Z1, Z2 over Z1 plus Z2. Now, the same thing you can do for Z12 when V1 over I2, when I1 is equal to 0. I1 equal to 0 means this is an open circuit. That means there is no current that is either flowing in here or there. And the V1 is going to be simply the potential drop over ZA. So this is nothing but, if you were to see, this is going to be then you're having a V1 which is over here. The VAB is going to be ZA over ZA plus ZB. If this is ZA and ZB, if I call this voltage to be VAB, for example, there is no current flowing in here. So I'm just going to find the voltage across ZA, where this voltage across ZA and ZB is VAB. Let's call it VAB. Let's call this guy VAB. So this voltage across A is going to be V1. The voltage across A is going to be V1, which is ZA over ZA plus ZB times VAB. So this is basically the voltage divider. Once you have that, you can write it in terms of I2, so that Z12 will become this expression over here. Similarly, by the similarity, right, you can replace the A by the C. You can replace the A by the C to find the other expressions. So you can even derive the Z parameters for a network like this.